Okay, I'm back. I am on page whatever. Hopefully you're watching these in order. I think I'm on page 215. And so rather than watch you make me go through these, you should just play around with your calculator if you're not positive of what curves to use. But I wrote down some samples of what I think the answers would look like. So maybe pause the video and copy those down, or pause the video and compare, or maybe I'll just talk long enough for you to actually have read all of them. But anyway, what I'm going to do is I'm going to move on to the next thing, which is pretty interesting. So uh, we want to write equations now for graphs. So it's going to combine like everything that we know, parametrics, polar, the special polar curves, and let's see if we can do it. So what I want you to do when you start these problems is focus on the polar curve, right? Figure out where the origin should be. So for this first curve that we're looking at, here, this is definitely where the origin should be for that, right? So that is the 0.35. So let me just make a note of that. 3.5 is the origin. So I'm going to end up with like x plus equals 3 plus something, y equals 5 plus something. And the somethings will be r cosine and r sine. Now I need to focus on what is r. Well, it's definitely a rose curve. I see 5 petals. I see 1 petal on what would be the positive x-axis. So if you dot in, you really don't need to dot it in, but if you dot in the x and y axes through the origin, you can see it's definitely on the positive x, which means that we're dealing with a cosine rose curve. And the distance from sort of where the origin is to the tip of this thing is 3. So I know that it's r equals 3 cosine of 5 theta. And now I just need to put that information together, right? So down here, hopefully you were writing that as we were doing it. We're just going to write x equals y equals. All right, so it's 3, 5, I think. Yeah, 3, 5, and then 5 petals and 3. A lot of 3s and 5s in this. Okay, so it's going to be plus 3 cosine of 5 theta, and then cosine theta. Don't forget that. I see a lot of people forget that. Cosine theta, and this will be plus 3. So this is r, like it's got to be the same in both equations. And then this will be sine of theta because we're converting the y coordinate. There we go. So that's all there is to it for rose curves. So rose curves, it's like decide is it sine or cosine. Once you've made that decision, how many petals are there, right? And don't forget, if it's an even number, you get 2n petals. So if you see 8 petals, then n is actually 4. And then figure out where the origin is. Just kind of do all the polar stuff that you know how to do. So let's do another one. See what happens. All right, so this one is a limison. Oh my gosh. I look at that and I can see it's definitely a negative sign, right? Like I just know that. But I'm going to do this in like a slightly different way, I think, right? So the origin should be here. So let me dot in something. So this would be the x-axis, and then this would be the y-axis. Okay, once I have that, I can start thinking like, when theta equals certain things, what does r equal? So I'm going to make a table, and it's going to be theta and r. Okay, so when theta equals 0, r is 2, because I'm 2 away. So that's this point right here. 2 units away from where the origin should be. That's when theta equals 0. When theta equals pi over 2, so don't worry about when you get to the origin, right? Those are those weird zeros of the polar graph. And looking at this, like you can't just tell offhand what those will be. But the key points are what really matters. So when theta equals pi over 2, I know that I'm here. And actually, I'm on the negative axis, which means r must be negative. So I know that at pi over 2, r is negative 2. And then when I get to pi, I'm at this point, r is definitely positive 2. When I get to 3 pi over 2, r is going to be whatever this distance is. So from 7 to 1, so 6. So it's going to be 6. 1, 2, yeah, 6. Okay. So now what I want to do is I'm going to take these points that I have in my table, and I'm going to turn those into a rectangular graph. So if I do that, so I'm hoping that you have them written down. I know that I need to go to -2, 2, and 6, right? So we're searching for what r is equal to. So when theta equals 0, we said r was equal to 2. And then let's do 2 pi, pi, there and there. When theta equals pi over 2, r is -2, so we're down here. And then when theta was equal to pi, we were back at 2. When theta equaled 3 pi over 2, we were out at 6. And then if theta equals 2 pi, we'll get back to the beginning. So look at this. If you've been watching all the videos, I have mentioned many times that your ability to write the equations of these things is just so crucial when you're doing almost anything in math. So this is definitely r equals 2 minus 4 sine of theta. So 2 minus 4 sine of theta, start in the middle, go down to a minimum, back to the middle, go to the maximum. And then the origin was shifted to 4, 7. So we're going to combine that information. I hope that my face is not like in the middle of all this work. I feel like it might be. Actually, wait, let me think here. Can I move? Can I move myself? Can I always move myself? I'm actually just recording my screen, so it occurs to me that yes, I can definitely move myself. That was ridiculous. Okay, so we're going to have x equals y equals, so we said it was 4 and 7. And then our polar curve is 2 minus 4 sine theta. And then that'll be cosine theta. Skipping some parentheses here for space reasons. And then 7, it'll be our polar curve, 2 minus 4 sine theta. And then sine theta. All right. And we're going to keep going. I think I'll stop this one here in case you're like fully confident you know what you're doing. You could stop and just go on your own, or come back for the next video where I'm just going to keep going. All right.